Recording has started. Okay, so this chart right here are the different chemicals we are going to mix with water and see what their reactions are. So basically what we have is ES is Epsom salt, CA is citric acid, BS is baking soda, LA is lemonade, because I couldn't think of a two-letter combination that was good for lemonade. OO is olive oil, and CO is coconut oil. And we have those going down the left-hand side of the chart and then also across the top, the same exact chemicals. And then you can see, we're not going to try Epsom salt and Epsom salt. We're not going to try citric acid and citric acid. So that's why I have those X's going right down through the center there. Let's see, what do you guys, I'm pretty sure, let's see.
Mr. Schillinger?
Yes.
The screen keeps popping up. I can't see.
It keeps locking up?
It keeps coming in and out of focus.
That's kind of strange because it's not doing anything to me. So, I mean, is it maybe because, like, maybe when I move the desk. Is it stationary right now?
Yes.
Okay. I need to buy a new camera. I need to get a camera that has a mount instead of clipping onto the top of my computer. Manvitha, yes, we do copy it down. I really can't move close to the board. Let me do this. Can you guys still see the board right now while I'm on another screen?
It's out of focus right now.
Okay. Give me one quick second. Like I said, I am just not prepared this morning. So table 2, 3, 4, 5, 6. So if I go. Still out of focus?
For me, yes, sir. I pinned your video, but it's still really blurry.
All right, I'm creating this graph for you, and I'm going to put it in the Google Classroom in just a second. Give me just a second. I'm sorry, guys. Really not, you're not going to let me add in another. I'm just having one of these days. All right. If you go, hold on. Almost there. While I'm doing this, so did everybody have a good weekend?
Yes, sir.
You guys get me lots of candy?
I did not get any Reese's peanut butter cups, unfortunately.
Oh, I'll take any candy.
That's nice.
Yeah, my son did pretty good. We ended up going to Siloam Springs where his sister lives.
I had a horrible hour.
Why?
Yeah, my parents got a bunch of candy for us. I ate it all throughout a movie, and I was so sick the next day.
Yeah, you're not really supposed to eat that much candy at one time.
I just kept on eating it. It tastes good.
Yeah.
So I was so upset. I refused to get out of bed. I actually burned calories.
You burned calories?
No, we decided to go on a 8 mile in camp backpack hike to the middle of the woods and then camp there for Halloween night. It was pretty fun. We heard coyotes howling, and there's this monster that ran by camp in the morning.
Hear any good spooky stories?
What?
Hear any good spooky stories?
No. By the time we got there, we were because it's all mountains and hills and uneven territory. By the time we actually got to camp, we just wanted to go to bed. So not very. It was like 30 degrees out.
Okay, guys, if you now look in the Google Classroom, there I've made the chart, and let's see, was it? Yes, even if you made the chart last time, I want you to still go ahead. You don't need to copy it down. I know I told you. Well, actually, you can go ahead and do this now on the Google Classroom. Except for I bet you anything, I made only one copy for everybody, didn't I?
Yeah, you're gonna need to make a copy.
You know, I just need to go home and go back to bed. I'm going to delete that real quick.
We can make a copy,
And I did a pin it.
Yeah, just go ahead and do that. Just make a copy of it.
and then attach it.
Yeah, when we're done.
Should it?
Okay, now I'm going to go ahead and recreate these. If you have the materials, you can go ahead and do them along with us.
Wait, Mr. Challenger, do we attach a photo of our chart to the assignment?
No, I've actually made the chart. The chart is there for you.
Okay, thank you.
You're welcome. I had planned on being back in the classroom to get all this ready a lot earlier than I did. But then, like I said, things happen. I got sidetracked, started talking to teachers and students. All right, so Rachel, are you there?
Oh, yes.
So remind everybody, what is a universal solvent?
It's what you put for each one.
Okay, but there is a very specific thing that is a universal solvent.
Oh, water.
Water. So obviously one of the ingredients was water that we used. And let's see, make it so you guys can see me now. There we go. We are not putting water on this list because water is going to be what we are going to use to dissolve everything. So the first one we're going to do is Epsom salt and citric acid. And I'm just going to do a teaspoon of each one. Put the Epsom salt in there, dissolve it. Then I'm going to get a teaspoon of citric acid. And dissolve it. Let's see, looking at these comments real quick. So for the first one, I'm just looking at the list right now.
Mr. Schillinger,
Yes, sir.
my internet is really slow, so the chemical reaction chart is still loading for me.
Okay.
So I haven't made it yet.
You can even just write these down on a piece of paper. So I just mixed citric acid and Epsom salt, and we had no reaction. So in that column, or for that mixture, just put NR, no reaction. And I'm putting these down as I do them as well. So, Maverick, while your internet is loading up, what are the two parts of a solution? Do you know?
My name's actually Merrick, not Maverick.
Wow. I know that, Merrick. I'm really sorry, Merrick.
It's fine.
No, it's not. My apologies. So, Merrick, what are the two parts of a solution?
I have no idea.
Okay. So, we know what the name of a solvent is, or what the name of the universal solvent is, which is water, correct?
Yes.
Okay. So would one part of a solution most likely be a solvent?
Yeah.
Because it must dissolve everything, so we use a solvent to dissolve. Now I just put in Epsom salt again in here. So the second part of a solution, you have a solvent which is doing the dissolving, and what gets dissolved is called a solute. S-O-L-U-T-E.
So it's like solvent and then a solute.
Right. A solvent dissolves a solute and forms a solution.
Okay. Let me write that down.
Yep. So, Sanish, there is a chart in the Google Classroom that shows, it has a bunch of letters on it. ES is Epsom salt, Ca is citric acid, BS is baking soda, So we're writing down the reactions that we get when I mix these things together. So right now I just mixed in Epsom salt and baking soda and nothing happened. So again, no reaction.
Mr. Schillinger, you said solvent plus what equals solution?
Solvent plus solute. SOLUTE. Yes, and Reese has it down in the chat. The solute and the solvent. Solvent dilutes or dissolves the solute and makes a solvent. And Sanish, yes, NR works great.
Mr. Schlinger,
Yes.
so on the chart, do we put so for example we did citric acid and Epsom salt.
Right.
So do we put that in both areas where those collide, or just one?
Yes, in both areas. Anywhere where they collide, we are putting them together.
Thank you.
No problem. All right. So we're just going to go down this list with the Epsom salts right now. So if something dissolves, like in this one, I'm taking Epsom salt and I'm putting it in the beaker and I stir it, my Epsom salts dissolve. Okay, so the solution has dissolved the solute, my solvent has dissolved the solute and has made a solution. We call this soluble. It is something that has been able to be dissolved. Where is my lemonade? Hold on. Somebody stole my lemonade. I'll be right back. Hello. Well, tell them they don't have to have that. It's that simple. Mm-hmm. They are not required. Okay, so lemonade. So going back to the words that I just used, Shrag, what is it that we call something that dissolves? If it dissolves in a solution, it is known as being what? Soluble. Okay, so again, lemonade, Epsom salt, no reaction. So far, this is being kind of boring. And that happens, you know. We don't always get a reaction out of everything. Go right up on my board. Okay, so if we have a word soluble, and we know that that means dissolves in, or it has the ability to dissolve, when I get something that can't be dissolved, if you were going to take a wild guess movie, what do you think we would call something that cannot be dissolved? Doing olive oil right now.
Unsoluble.
Close, very close. Instead of saying un, though, we use the word insoluble. So very close. You know, non-soluble, unsoluble. Those are very logical words to use, but the actual word that we're using, and there's probably some more precise reason to use that word. I am definitely not an English teacher. Epsom salt and lemonade was a non-reaction, correct, yes. Now, you may also note that everything dissolved until we got to the olive oil. The olive oil was insoluble. And let's see here. Addison, are you with us today? Miss Dawlings? Okay, so Epsom salts and olive oil, no reaction, insoluble. They did not dissolve together. So everything so far, yes, has been non-soluble. Okay, Angelina, are you with us?
Yes.
Okay, based on our experiences so far, I have dissolved the Epsom salts in our universal solvent, in our water, and I'm getting ready to put in coconut oil. What do you believe is going to be the outcome?
I think it's insoluble. The type of oil does not mix well with water at all.
Okay, so she is saying that olive oil will be insoluble.
Wait, Mr. Schillinger,
Yes,
what was the abbreviation for coconut oil?
CO.
Because on your chart there were 2 CAs and there was no CO.
Yeah, I think the last one's C.
Ah. See, this is what happens when you are in a big hurry. Because
You're virtual.
because I am an unprepared person. Yes, the last 2 CAs should be CO. I am.
Was I right in the reaction?
What's that?
Was I right?
You were 100% correct. Insoluble. It's what's liquefied is floating on top, along with the chunk. So very good. All right, go rinse these beakers out real quick.
Mr. Schillinger?
Yes.
So basically everything is NA so far, right?
NA or NR. But yes, you're correct. So now my first question then, if Epsom salt did not create any kind of reaction in the water, why is it something that is in all of the bath bombs? Anybody want to try and take a guess on that?
Maybe like the smells or the oils or something in it.
All right. Manvitha, you had all the chemicals.
Yes, sir.
Do you have the bag of Epsom salt with you?
Unfortunately, I do not.
Okay.
It was actually Alexa who had everything. I just had everything but lemonade and Epsom salts and citric acid.
Okay, so Epsom salt, and I guess you're looking at this backwards. It tells me that one, Epsom salt is a saline laxative for release of constipation. Well, I don't want that to happen while I'm in the bathtub. Hopefully you know what that is. I don't want to go into detail about that. But that's only if you drink it. Soaking in Epsom salt is good for aches and pains, sprains and bruises. So if you are wanting to relax in a bath, wouldn't it be nice to have something in the water that helps your muscles? So yeah, it's going to be in there just to make you feel better, to make your muscles feel better. Because now, I mean, you guys are kind of young, but that does not mean that you don't like to, you know, get in some water and just kind of relax a little bit. But a lot of people do. They like just to get in the water and relax. Let it make them feel good. And that's what Epsom salts does, is that it helps your muscles relax. It makes them feel better. So that's why we'd put Epsom salt into the water. Kind of makes sense? Okay. So we've completed all the Epsom salts. Now let's look at citric acid.
So now it's water and two chemicals.
Yes, that's what water is a given on all these. I'm not listing water because water is our universal solvent. Yes, so Nish, remember though that last Ca should have been turned to Co. That was a typo on my part. You get that, Sanish? Okay. So I have dissolved the citric acid and I got baking soda right here because we've already done the Epsom salt. I don't need to try Epsom salt again. Alexa, are you with us? Alexa, what do you think is going to happen when I put the baking soda in with the citric acid? Alexa says it's going to fizz. Come on now, everything I've tried so far, nothing has worked. And you think this is going to make a fizz. Let's see. Very much so. As soon as I put it in, didn't even have to stir it. Started fizzing, lots of bubbles, a lot of stuff coming out. Got a whole bunch of baking soda that's around the edges of my glass. Got water all over my computer and my desk. So yeah, put reaction, maybe even put a fizz. So Avinash, that was citric acid and baking soda, Ca and Bs. Okay. Finally, we saw something that did something. Okay, let's try. Oh, I need a new spoon. I think that one has baking soda on it still. All right, so baking soda, citric acid, stirring it up. We're going to get some lemonade.
So this is citric acid and lemonade then?
Citric acid and lemonade, yes ma'am.
I don't think there'll be a reaction.
Okay. Let's see here. Lexi, are you with us?
Yes, sir.
What about you? You think there's going to be a reaction?
Well, since it had citric acid, I do, and it has water, so I think it will.
Okay, so citric acid and lemonade.
I heard a little fizzing sound, but it didn't really do much.
No, I really think that that was a residue. Let me get a completely clean beaker and try that again. Okay, so there's citric acid. Yeah, that time no fizzing noise, so there might have been a little residue of something in there.
So no reaction.
No reaction, just dissolved. It's soluble. Yep. Running out of clean beakers here. All right. Citric acid. Stir, stir, stir. Lauren, are you with us?
Yes.
All right, so Lauren, I am going to put olive oil into my beaker of citric acid and water. What do you believe is going to happen when I put the olive oil in?
I don't really know. I don't think it's gonna fizz or anything.
Let's see.
Me too. I don't think anything can happen.
I'm going to stir it up. No reaction whatsoever. And again, the olive oil is formed a layer up on top. So the olive oil is insoluble.
That was with the lemonade mixture, right?
No, this was olive oil and citric acid. And we have one more citric acid to try. And get me a good spoon. Okay, citric acid in the water. Completely dissolved. And Jay, are you with us? No, Jay?
Yes.
Oh, okay. Jay, coconut oil and citric acid.
No, I don't think so.
You don't think so? Looks like Jay is correct. So got a oily film up on top. Still some of the coconut oil there. So once again, insoluble and no reaction. All right. So that just leaves us baking soda and lemonade to go with the oils. Excuse me. So let's try some lemonade. Now, chances are the lemonade and citric acid, if we were to drink that, it would have been very sour. It would have been very bitter. Because I think Manvitha may have said it, but what's that?
I kind of lost track of what we were on.
Okay, so we are doing lemonade now. So what we did is we just finished up citric acid. For citric acid and baking soda, we had a reaction. It fizzed. Citric acid and lemonade, no reaction, but it did dissolve. Citric acid and olive oil and citric acid and coconut oil, no reaction, but it did not dissolve in either one of them. So they were both insoluble.
So we're on lemonade now.
We are on lemonade, and we are going to try, oops, my bad, I skipped baking soda. It's all right, we'll come back to that one.
We're on lemonade and baking soda, right?
Yes, lemonade and baking soda. So I have the lemonade, baking soda, and it fizzed. Not as much as the citric acid, but it definitely fizzed. Lemonade was LA, correct, Vedant? And I forgot to ask somebody what they thought was going to happen on that one. I'm sorry.
So are we supposed to be putting LA and NA, or just like NA and fizzing, or like what are we supposed to be filling out in the chart?
You should be putting whether or not it is reacting, and be a good idea also to just put whether or not it dissolves.
Okay, so I've just been putting NA for like no reaction or nothing happened, and then fizzing for when it fizzes.
And that's fine. I mean, that's basically the main thing we're going to be seeing. So
Okay.
you're good there.
Okay, thank you.
You're welcome. All right. We're going to go ahead and finish up with the baking sodas first because I had jumped. So that was baking soda and lemonade. Now I got baking soda. It dissolves. I get my olive oil. And Vedant, what do you think is happening?
No reaction.
No reaction.
The oil just sitting on the top.
Yep, it is. It's just an oily film up on top. I don't know if you can, that's actually a good view right there. Kind of. Too far. This was olive oil, OO, and BS, baking soda, correct. So interesting thing about oil, like olive oil, have you guys ever heard of a lava lamp?
Yes, sir.
So that's basically all a lava lamp is water and oil. And the light bulb heats the oil, which we really don't talk about this much in class, but it's density. The oil is less dense than water. But when the oil gets heated up, it becomes actually more dense than water. So it sinks and it rises, it sinks and it rises. So as we're heating and cooling the oil in the water, the density is changing back and forth, which is why a lava lamp will send the globs of oil up to the top and they come back down and it keeps changing back and forth. Very, very simple scientific properties, made everybody very fascinated for years. All right. Clara. How's Clara doing today? So Clara, baking soda has been dissolved in the beaker, and I'm getting ready to add olive oil. What do you believe is going to happen? Clara says nothing.
You mean, was it coconut oil?
Yes, it was coconut oil. Guys, I think I need a reboot on this day. I probably haven't got enough candy today, that's why.
Mr. Schillinger, will you put up a recording of class today?
Yes, it is being recorded and it will be put up as soon as we're done.
Okay, thank you.
You're very welcome. So, Clara, you were right. Baking soda and coconut oil, BS and CO, do nothing, no reaction. The coconut oil, like all the oils so far, have been completely insoluble. They're not doing anything. All right. Lemonade and olive oil. I'm out of spoons. Hold on one second, guys. Mr. Schillinger has to do some dishes real fast. Almost done. I can't have any videos of me doing dishes, otherwise my wife might make me start to do them. And that's just a joke. I do dishes all the time. The next is lemonade. So we got water and lemonade. Miss Beckwith? Lillian, are you here?
Yes.
Lemonade and olive oil. What do you think is going to happen?
I don't think anything's gonna happen.
You don't think it's going to explode?
No, not necessarily.
Oh, come on now. You have little faith. Oh, guess what? You were right. It didn't do anything. Again, just like all the oils, it floats up on top, meaning it's insoluble. It does not dissolve. So that leaves lemonade, and coconut oil for the second to last one. And let's see here. Samuel, you with us?
Yeah.
Is this one going to do anything?
I don't think so.
You, sir? We're correct. It just, I don't know how well you guys can see that, but the oil is just floating on top. One more time. Insoluble. No reaction.
Wait, was that the olive oil and coconut oil?
No, that was lemonade and coconut oil.
Oh.
Now, the very last one we have to do is water. Let me get my warm water. So I got some warm water here. Ah, there's some warm water. So, olive oil. So, olive oil and water straight off the bat. Completely insoluble. It all floats on the top. Miss Markham. Miss Markham. All right, Avinash. What's it going to do? Coconut oil, olive oil, and water. You say R for react. NR for not react. Which one? Okay. All right. Olive oil, coconut oil. Just a big oily mess. No reaction.
What was that one?
That was olive oil and coconut oil.
Oh, thank you.
Okay, so kind of not a lot going on in that lab. So obviously now we know that only two things created any kind of reaction. What were those two things, Aubrey?
What'd you say? You glitched out on my screen. You were glitching out.
Okay, what two things created any kind of reaction?
You were glitching out a lot, so I'm pretty sure it was the baking soda
Okay,
and the lemonade.
okay. Did you see the citric acid in lemonade?
A little bit.
Okay. And again, I would like you, I mean, if you can, go back and watch the video. But we definitely had a bigger reaction on the citric acid and baking soda than we did on the lemonade and baking soda. Rashish. Wait, yep. Rasheed, you with us?
Yes.
All right, so did I talk about why citric acid and baking soda would do any kind of reaction? Or do you know why they react? Any idea? Now, don't be Googling it. Google is our friend, but I want to see if you know why without looking up the answer yet. Nothing?
No.
Okay. Vaishnavi, any idea?
I don't know what the question was.
Okay, why are we getting a reaction from citric acid in baking soda or lemonade in baking soda?
Because maybe the acid reacts with the baking soda.
Okay. So are you saying that lemonade has acid in it?
Yes.
Yeah, it does. So Manvitha, obviously we know we have acid. We have citric acid, and because lemons are a citric product, we have citric acid in lemonade. What is the opposite of an acid? Do you know?
I'm sorry, I forgot.
Okay, no need to be sorry. Does anybody know what the opposite? And again, guys, don't Google this. I mean, we could all Google it and find out the answer. But does anybody know what the opposite of an acid is?
Maybe water.
No. To tell you the truth, water is in between an acid and the other side of it. What do we call an alkaline, Alexa? I'll give you guys a hint. It starts with the letter B.
It's a base.
Very good, Samuel. It's a base. So what happens is when I take something that's acidic and I take something that's a base, they attack each other, for lack of a better word. They react strongly with one another to neutralize one another. And as a result, I'm breaking down molecules and I'm getting water in return. Water is neutral. Water has zero acidity to it and zero alkaline or zero base to it. So if you ever get an acid burn, you're supposed to put baking soda on it. And I mean, I got a bunch of acid burns on my hand. I had a battery crack open one time on me. And when it started burning my skin, my friend grabbed a bunch of baking soda, put it on there, and it helped a lot. On the opposite end of that, when I was in the Navy, I got a base burn on my leg. I got a burn of sodium hydroxide, which is a base. And they actually had to put a silver acid on my leg. Yes, I was in the Navy. Um, to counteract the burn that I received on my leg. My whole knee to the middle of my shin had turned black from the burn. What do you mean, Vedant? Something wrong with the Navy? Thank you very much, Alexa. It was my pleasure. So what we are seeing is we are seeing a reaction between acids and bases. Oh, Vedant, there's a lot of things I've never told you about myself. I'm a man of many mysteries. But I was in the Navy for little over 7 years. Um, I'm a disabled vet. I've injured my back when I was in the Navy, and it actually is why I am a teacher. When I was doing all my medical stuff, I started working with young people and decided I wanted to be a teacher. So the Navy led me here to you guys. So we're going to wrap it up right there. That we have seen a reaction between acids and bases. We learned last Wednesday that matter, actually, let's do this. Shrey, are you still with us?
Yes.
Okay, Shrey, on Wednesday, we did some reactions with the bath bomb, and I gave you the law of conservation of mass. Do you remember what the law of conservation of mass was?
No, I don't think so.
Okay. Um, how about Merrick? What was the law of conservation? Oh, Sanish just answered it for us. So the law of conservation of mass is that matter cannot be created nor destroyed, only rearranged. So what we're going to start investigating, what we're going to start looking at in our next class is if matter can't be created nor destroyed, and we're making a gas that we know is not trapped inside the bath bomb, where is the gas coming from? Why when I put acid and a base together, why is it making this gas? How is that gas coming to be? All right. So that's where we're going to be headed on Wednesday with that. So what I'd like you to also be doing on Friday, we are probably going to go ahead and start another Genius Hour. So start thinking of some ideas that you may want to do for your Genius Hour. And we are going to end class on that note. Does anybody have any questions for me? Make sure you submit this sheet to get credit for it for today. And ladies and gentlemen, I will have this video posted in about 10 minutes for those of you who had some issues looking at the video.
Mr. Shilling.
Yes, sir.
So on what do you want exactly on like the document? I haven't been able to open it, but I do have like the picture of it.
Okay, all I want you to do, thank you very much, Lillian, is to go ahead and write down which ones had a reaction and which ones didn't. And I'd also like to know which ones were soluble